Any other questions regarding the assignment from anyone? If not, I think we can get started with today's stuff. And today it's just about inferential statistics. So we are not even going to dive deep into our slideshows. We're just going to be working off of what we have already done. So we will start using the same data that we have used previously. In our working session, we'll just use the same food sales data that we have used previously in the first two sessions, and we're going to try and answer some questions about it. And then tomorrow on the same data, we'll do some more visualizations. So you get the journey of that data being a single sheet data to all the way to a polished presented a polished presentation. So that's where we want to go from start to finish. Before we get started, by a show of hands, how many of you have, I think, let's do one thing. Everyone put your hands up. So just raise your hand. Yeah, everyone do it. Yeah, regardless. Yeah. Okay, go ahead. Some of you are still not listening or anything. Okay. Yeah, I think. Okay, I think only 9. Okay. Okay, so I get an idea. Okay, so 9 people are listening. Okay, so put your hand down now. This is just giving me an idea of how many people are paying attention. Now, put your hand up if you have worked with inferential statistics. You understand, if you understand what ANOVA does, when to use ANOVA, if you understand the t-test and when to use t-test, just put your hand up if you understand that stuff. अगर आपने पहले t-test ANOVA ये सब यूज किया हो तो अपना हाथ ऊपर करो. Okay. And if you have never used it, अगर आपने कभी उसे यूज नहीं किया है तो भी अपना हाथ ऊपर करो. Okay. So it seems like आप में से कईयों ने उसे कभी यूज नहीं किया है. Okay. The trick is now the difficulty is I want to teach. मैं सिखाना चाहता हूँ कि कैसे ANOVA or t-test generate की जा सकती है. That's what I want to teach. I want to teach how to generate those tests and how to get your data ordered to generate those tests. But if I will try to touch as much as possible on the concepts of ANOVA and t-test. This session is about how to get to that point, how to generate those tests, and not specifically on what those tests do. So I'll try my best to cover both, but I think my main focus would be on generating these tests and see if we can generate these tests and understand what they're trying to do. All good? Any questions? There are a few raised hands, but I'm not sure if that's for questions. Okay. All good. Okay. Let's get started. Before we get started, there's a few things we will need to do. So हम थोड़ा बहुत setup करेंगे. सबसे पहले सिर्फ Excel का setup करते हैं. So if you have Excel open, अगर आपका Excel अभी खुला हुआ है, go to File, go to Options. So go to File, go to Options, go to Add-ins, Files, Options, Add-ins. वहाँ पर जाओ. Manage Excel add-ins. में गो क्लिक करो और just make sure this analysis tool pack is clicked. ये है, just make sure कि ये टिक किया हुआ है, then click OK. And when you scroll over to your data section, you should see data analysis on the far right hand side.
Is there?
Everyone
I
following?
mean, on MacBooks, is are the options same? Because I cannot see same options on MacBook.
MacBook, I'm not sure because I've never used MacBooks. Okay, so let's do it this way, Gaurav. So you can go to File, you can go to Options, right? That exists.
No, it doesn't exist. That's the problem. I went there, and the very first step is not there.
Okay. Are you using the app or are you using the browser mode?
No, I'm using the app.
The app, it doesn't exist. Okay. Wow. This is. I have no clue how to do it in. That the MacBook question is a new one. Let me figure it out, and I will follow up with you, Gaurav.
Yeah,
I'll probably show it to you. I'll just Google it on the side because I'm unsure as well. Anyone else having any issues with this add-in stuff?
So if you could please just repeat one more time.
Yeah, sure.
So just repeat.
Okay. Yeah. So just go to File, Options, and then go to Add-ins. File, Options, Add-ins, and in Add-ins, go to Excel Add-ins. Just make sure that this add-in is ticked. Sometimes you might not even have it here, so you might have to just make sure. First of all, do you see it here? Just let me know first that you see it here in inactive application add-ins. Do you see it here?
Yes.
Yeah. Then just go to Manage, click it, and click OK. Okay, Gaurav, I think go to Tools. Do you have Tools on your menu? Tools menu.
Yeah.
And
I do.
Can you see Excel add-ins?
Tools, Excel add-ins. Yeah.
Yeah. Go to Excel
Analysis
add-ins.
toolpack and yeah.
Data analysis toolpack. Yeah. Just make sure that is active in your
Okay,
system.
and just clicking on OK. Right.
Yeah.
Okay.
Now go to the data tab, and can you see the data analysis here? The data analysis tab here.
Data. Yeah, I can see it. Yeah, I can see it. Thank you so much.
Yeah, no worries. Sat, can you see it?
Yes, sir. I can see.
Okay, good. Everyone can see it. Give me a thumbs up of all that you, if you can see it. Okay. Who cannot see it? Just raise your hand. Pratibha, you can feel free to unmute if you can't see it. Yeah, you can unmute.
Hello, sir.
Yeah, go ahead.
Yes, sir. Good morning, sir.
Good morning.
Sir, actually, I don't have Excel app on my laptop.
Okay.
So, yes, I'm using it in Chrome, but I'm not able to see the options in file thing.
Yeah, so that's the problem with browser extension, that you'll probably not have it. ये browser में नहीं मिलेगा, ये सिर्फ app में ही है. तो yeah, so वो एक इसकी problem है. So आपको क्या करना पड़ेगा कि अगर आप अभी सिर्फ सीख लीजिए और फिर
Okay.
फिर अगर आपके पास कभी ऐप का एक्सेस हो तो आप तब आप इसे प्रैक्टिस कीजिए आफ्टर द क्लास इफ पॉसिबल.
Okay, sir. Okay. Thank you so much, sir.
Okay.
Thank you.
No worries. Neha, after add-in, what do we have to select? So, okay, I'm just going to repeat it once more. So go to File, Options, Add-ins. Once you are in Add-ins, Manage Excel Add-ins, go. और यहाँ पर ये जो एनालिसिस टूल पैक है इसे टिक करना है. ओके. Is it clear, Neha?
Yes, sir. Clear. Thank you. Thank you, sir.
Okay, great. Okay, so that's the first step, getting the add-in, and now we can get started with some of the analytics. So I think I'm going to start off with one of the example that I've given you guys. ये data मैंने शायद दिया हुआ है. I think this is not the polished data. सबको data मिल गया? Everyone got the data?
Yeah.
Yeah. Okay, great. Okay, so this is probably what you guys have, the policy data. So what we're looking at with this data is that there is a policy number, an expiry and location with some other demographic factors and some building factors of the insured value. कितने के लिए एक मकान को इंश्योर किया गया है, उसकी इंश्योरेंस की वैल्यू क्या है वो दी गई है, और उसके साथ साथ उसका कंस्ट्रक्शन किस तरह का बिल्डिंग है और किस बिजनेस के लिए यूज किया गया है वो दिया हुआ है, और वो इंश्योर्ड है या नहीं फॉर अर्थक्वेक एंड फॉर फ्लड, ये दिया हुआ है. सो दिस इज just sample data that we will try and use to generate the one-way ANOVA, just the one sample ANOVA. हम लोग एक try करेंगे using this data analysis tool pack to create some tests. Okay, so let's try it. So anyone familiar? How many of you are familiar with one sample ANOVA, single sample ANOVA? Raise your hand. Enroll. Okay. Ashama. Okay. So, okay, one of you unmute and tell me what does the data need to be? How does the data need to be structured in order to perform a one-way ANOVA? अगर आपको पता हो, you can even type it in the chat.
So generally, like in a single test ANOVA, I feel like that. I mean, of course, there are two groups that we want to compare, like their means. But there must only be one dependent variable and one independent variable and one dependent variable.
Perfect.
Okay.
Yeah, perfect. So, मान लीजिए कि मेरा hypothesis है. Let's assume that my hypothesis is that the insured value has nothing to do with whether it is insured for an earthquake or not. That is my hypothesis. So the null hypothesis, मेरा जो null hypothesis है वो ये है कि earthquake के लिए एक बिल्डिंग को इंश्योर करवाना, उसके इंश्योरेंस की जो वैल्यू होगी उससे कोई लेना देना नहीं. ये मेरा null hypothesis है. अगर तो मैं इस null hypothesis को प्रूफ या डिसप्रूव करने के लिए वन वे ANOVA यूज कर सकता हूँ, क्योंकि इसमें सिर्फ एक ही डिपेंडेंट एक ही वेरिएबल है, और वो वेरिएबल है इफ इट इज इंश्योर्ड फॉर एन अर्थक्वेक और नॉट. यस, हम लोग बहुत सारी चीजें ओवरलुक कर रहे हैं, जैसे कि विच स्टेट द बिल्डिंग इज इन, what type of frame the building has, what type of business the building is used for. But for now, my only hypothesis is that earthquake के लिए इंश्योर करवाना और इंश्योरेंस की वैल्यू का कोई लेना देना नहीं. If that is the case, if that is my business question, then I can actually answer that using one way ANOVA. Okay, so in order to do that, in order to have data that you can test with one way ANOVA, let's say your data is like this. You need to make sure that your data is sorted according to your dependent variable, जो कि यहाँ पर है earthquakes. इसके ऊपर sorry, not dependent variable, to your independent variable. You have to make sure that this is sorted according to earthquakes. So what I'm going to do is to select the whole thing, and then I'm just going to do a custom sort, going to sort everything by earthquake. Okay, so now I have the insurance value when the earthquake, when it is not insured for an earthquake versus when it is insured for an earthquake here. This is when it is insured for an earthquake. So now I can actually generate the one-way ANOVA. So the simplest way, it's actually pretty simple. So you go to the
Sir.
data analysis. Yeah, go ahead.
Sir, again repeat, sir. Actually, I didn't understand, sir.
Yeah, the sorting, the data sorting.
Yes, sir. Yes.
Yeah, okay. So if you have your data structured in a way जहाँ पे आपका जो in this case your test, what are you testing, मतलब आप क्या टेस्ट कर रहे हैं? आप ये टेस्ट कर रहे हैं कि इसकी इम्पैक्ट, क्योंकि ये ऑप्शनल है. आपको अगर अर्थक्वेक की कवरेज लेनी या नहीं लेनी वो ऑप्शनल है. उसके ऊपर आपकी इंश्योरेंस वैल्यू चेंज होती है या नहीं होती है. हमारा नल हाइपोथेसिस है कि इसके ऊपर कोई असर नहीं पड़ता, पर हमें वही टेस्ट करना है. सो दिस इज द इंडिपेंडेंट वेरिएबल, दिस इज द डिपेंडेंट वेरिएबल.
ओके सर.
यहाँ तक क्लियर? ओके. अब हम क्या करेंगे, इसको अनोवा को यूज करने के लिए इट इज वेरी इंपॉर्टेंट कि आपके दो ग्रुप्स बहुत वेल डिफाइंड. तो वो जो दो ग्रुप होगा, एक ग्रुप होगा कि जिसमें अर्थक्वेक का इंश्योरेंस नहीं है, दूसरा ग्रुप है कि जिसमें अर्थक्वेक का इंश्योरेंस है. सो हम क्या करेंगे, उसको सॉर्ट इस तरह से करेंगे कि पहले जिसमें नहीं है वो ग्रुप आएगा और बाद में जिसमें है वो ग्रुप आएगा. तो ये इंडिपेंडेंट सॉर्टिंग हो गया कि आप एक क्लियर मार्कर है कि यहाँ पर अर्थक्वेक, बिना अर्थक्वेक के इंश्योरेंस वाले घर हैं और यहाँ पे अर्थक्वेक के इंश्योरेंस वाले घर. तो एक बार अगर once you have that distinction, you go to the data analysis pop-up, go to ANOVA single factor, click OK. Now here हमारी जो input range है, that would be group by columns. Oh, sorry, completely messed up. Okay, I was talking about the t-test, not the ANOVA test. Okay, Ashima, go ahead. You have a question? Ashima, you have a question?
I actually had a question. So
It's
Yeah,
okay,
please
sir.
go
I
ahead.
understand. No,
Sorry.
nothing, sir. Nothing.
Okay, no question. Okay, Gaurav, go ahead. You had a question?
yeah, actually, I wanted to ask, like, how did you sort this? Like, I mean, the no's are coming first, then the yes in that earthquake section. So, like, how did
Yeah.
you do that? I just missed it.
So just select your entire table.
Okay.
Go to home, go to custom sort,
Okay.
then you go to sort by earthquake. So sort by earthquake,
Earthquake.
and then
Yeah.
select A to Z.
Okay. Thank you.
Yeah, so that's how you sort it. Sorry, so scratch all of that. I was saying I was talking about the t-test. Sorry, not the ANOVA test. I got it all confused in my head. So that in the t-test, we are assuming equal variances, and we are using two samples. So the first sample is going to be the first sample is going to be the houses that have earthquake insurance, sorry, that don't have earthquake insurance, and the second sample is going to be the houses that have earthquake insurance. So two sample, assuming equal means, assuming equal variances. Okay, the first variable range. Go
So
ahead.
just-
Yeah. Hindu.
But then like one of the values are not numeric in nature, so would that not be an issue? Like for means, we need a numeric. It's ultimately comparing means, right?
Why is it not numeric? Because the first variable is going to be just the ones that have earthquake
that is
insurance.
numeric. But
The
other
second is
aspect of
the second is going to be the ones that do not have earthquake insurance. So this is going to be a second.
Okay. I
Yeah.
got it mixed up. Okay.
Yeah. Makes sense? Yeah. Okay. Good. I'm just going to use a 0.5 because that's just generally standard. Nah, let's leave it. I don't want to go into explaining that. Okay, and then once you click OK, it will generate your t-test. Now, okay, let me just first. This E stuff is really annoying, so I'm just going to convert it all into numbers because that's easier to understand. Okay. Convert it into number. Convert it to number. Okay. So the variable one was does not have earthquake insurance, and the variable 2 was has earthquake insurance. Okay, I'm just going to zoom in a little bit so you guys can see. Everyone can see? Okay. So our hypothesis was that having an earthquake insurance and not having earthquake insurance does not actually make a huge difference. I'm wondering why does it say 256 observations? Let me just double check my analysis. Sorry, just give me 1 second. I'm just going to double check because I'm not sure it's supposed to have. So F2 to 245. Okay, it's great. Okay, so it's fine. I thought, yeah, this is. Yeah. Okay, just making sure that my analysis is still good. Okay, so the first sample was supposed to be if you have earthquake insurance, what is how much are you paying for how much are you paying for the insurance versus if you don't have earthquake insurance, how much are you paying versus if you have earthquake insurance, how much is the insurance? So we got 245, 44, and 255 observations between the two. And what are I can go into these, but it's just going to take all day. So we'll just have to do inferential statistics if we want to understand different tests. That has to be like a completely different lecture series. I'm just going to try to answer the question whether it proves that our hypothesis is true or false. I will just keep it to that. We can go into more of the hardcore statistics of stuff, but that has to be a completely different lecture series. Okay, so our p-value. So the p-values are what decides whether your difference is significant or not. So what is the difference right now? How much difference do you see? So you see this. Difference in variance and then the difference in means. Okay, difference in variance doesn't mean that much. Yeah, difference in means. So what we are seeing is that if you have earthquake insurance, if the average insured value is going up quite significantly higher than the mean value, and this is proven by our p-value. Our p-value suggests that if you have earthquake insurance, the p-value doesn't actually suggest that one is greater than the two-tailed one. It does not suggest that one is greater than the other or not. So if your null hypothesis is there is no difference between the mean of assured values, especially when you have bought the earthquake insurance or not bought it. So earthquake insurance has no impact on the mean values of your insured value, then that hypothesis has been rejected. This does not prove that it means that it is higher. It does not prove that. It just proves that in a two-tailed test, it just proves that it is different. So it just means that the means are vastly different when you purchase an earthquake insurance versus when you do not purchase an earthquake insurance. When you do more of a one-tailed test, that is when you can go into the greater than or less than equal to. Make sense so far how to generate these analytics and how to read them? Are you guys still following, or yeah? Little confusing. Mahesh, just can you confirm, because yeah, I think we'll probably have to take that as a caveat. Have you used t-tests and stuff before? That's probably going to be that probably will help me in explaining this more. Explanation part. Okay.
I mean, actually, how you explain that table, the
Okay.
null hypothesis.
Okay. Okay. So how we explain this table? So what do we get? So what were we comparing? Let's start with the null hypothesis. The null hypothesis was that the mean insured value does not differ, is independent of this variable, that is the earthquake. So there is no difference whether you have earthquake insurance or not on the insured value. That is our null hypothesis. What our t-test does is it checks the means and sees if one mean is significantly different from the other. वो सिर्फ यही चेक करता है कि एक मीन दूसरे मीन से अलग है या नहीं. Especially in a two-tailed test. जब आप एक two-tailed test करते हैं, two-tailed यानी इसके लिए शायद मुझे लगता है कि काफी डीप statistics में जाना पड़ेगा. Just give me 1 second. एक मिनट, मैं कुछ एग्जांपल दिखाता हूँ. इमेज पुल करने की कोशिश कर रहा हूँ. ओके. Full screen. Okay. Okay. So this is how many of you are familiar with the distribution of data, like especially when it comes to the normal distribution? The normal distribution. If you're unfamiliar, please raise your hand. If from normal distribution. Okay. Okay. Couple. Oh, okay. 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 So I probably misjudged today's lecture, but I think I will try my best to explain this as quickly as possible. Normal distribution basically suggests, normal distribution का suggestion होता है कि जो भी data है, data is usually structured along its mean. So the point where most of the distribution of your data lies between in this sort of a bell curve where it congregates at the mean. Matlab, mean is equal to median is equal to mode. Mean, mode, and median are the central points of your data, and your data is structured along it. So for example, I think a great way to understand that would be distribution of height. Let's say अगर आप इंडिया का height distribution देखने जाओ, what you will find is that there would be some average number. I don't know off the top of my head, probably 5.7 or something like that, where you'll find that most of India, 5.7 is not just the average height. The assumption of the normal distribution is that 5.7 is not the average height. It is the height that most number of people have. And it also divides the data into two equal parts. So there are equal number of people who have height less than 5.7, and there are equal number of people who have height more than 5.7. Make sense so far, Gaurav?
Yeah.
So that's normal distribution, basically. That's the normal distribution. So it assumes that the data is structured in that way. Now, let's say you are comparing the heights of India versus, let's say you are comparing the height of, let's say South Sudan or something like that, where people are like really tall. When you compare the heights, you're comparing two different samples, and you're comparing the means of that. When you do a t-test, what you're trying to do is you're trying to see if the mean of India's height is significantly different from the mean of South Sudan's height. Now the South Sudan mean is like something like it's something crazy like 6.2, 6.3, right? So then when you do a t-test, you are checking whether there is a significant difference between the heights of India versus the heights of South Sudan. It doesn't tell you whether South Sudan is more than India or less than India. It just says that it is different than India. The more or less does not fall into a t-test sort of like a two-tailed t-test format. So if we understand this way, the two-tailed t-test, what does it say? It says that when something, how many of you? I'm going to assume that p-value is in a similar vein. I think. How many of you are unfamiliar with the concept of p-value? Okay. So I think probably would have needed to do more of this in terms of understanding the inferential statistics. So p-value is basically the probability that your mean is in the rejection region of the bell curve of the other sample. So for example, here you see, let's say all the data, this is like, let's say the height distribution. Okay, all the data is between like a height of 4 foot and like 7 foot. This is the height distribution of India, and 100% of the data is between 4 and 7. Okay, all of the data is between 4 and 7. There will obviously be outliers, but including the outliers, everything, the 100% of the data is structured along this bell curve, and only like people who have like crazy height, like 8 foot, are like on the far end of the data, and people who are who have some disabilities and are shorter than 4 foot are on this end of the data. 100% of the data is between these two, is along the bell curve and then along the outliers. That's where 100% of the data is. So this is the 100% of the data. Now, I want to capture just I want to make sure that the average height of South Sudan does not fall somewhere in this region, which is like, let's say, when you say that there is a 95, when you say that with 95% significance, what it means is that you are leaving out 5% of the outliers and just comparing the means in the, so you're leaving out the 0.25 on this side and 0.25 on this side. You're leaving out those outliers and you're just comparing the means between that region. So when what the p-value suggests is that, okay, go ahead. Someone had a question. All good so far? Yeah, so the p-value just basically suggests that your data, the probability of your data falling in their bell curve, in the significant region of their bell curve, what is that probability? If the probability is less than 0.05, it means that it is more likely to fall in the outlier section. So when the data is falling in the outlier section, it means that you can reject the null hypothesis, that there is a significant difference. If I hopefully this has so far made sense to the, okay, people who understand t-tests or understand p-value, people who understand it. Am I doing a good job explaining this? Give me a thumbs up, because yeah, I wasn't prepared with this one. Yeah, okay, great, okay, thank you. You're smart people, so okay. Okay, let's try to understand it this way. No, I can't spend too much time on this. We've got to move on. But hopefully that makes somewhat of a sense. How we compare variance. Go ahead, Gaurav.
Yeah, I did understand that, but like when you were explaining this whole table, so you said that there is a difference in the mean value, and we cannot really say that if there is a relation or not. So the relation cannot be established, right? So if there is an impact of earthquake on the values, right? So you're saying that this only shows that there is a difference in the mean value.
Yeah.
So, I mean, then why are we doing this test? Because initially we were doing this test to determine that if the earthquake determines the mean value.
No, I think so. Our null hypothesis wasn't that that one is greater than the other, or one is different than one is greater or less than the other. Our null hypothesis was earthquake.
Earthquake has no impact.
No impact. That there is no difference in the mean value of the mean insured value compared to the mean insured value, whether you get earthquake insurance or you don't get earthquake insurance. The value doesn't change. That is what our null hypothesis was. So when that is our null hypothesis, your alternate hypothesis or the opposite hypothesis is that there is a difference. That is our alternate hypothesis. That's the caveat, and that's why we are going to use a two-tailed test. We can't use a one-tailed test there. Make sense?
Okay.
Even though if you use a one-tailed test, it's giving that this is significantly bigger than that. The one-tailed test is significant, but we can't use a one-tailed test because our hypothesis was that it is different. It wasn't that it's less than. Make sense?
Yeah.
Mahesh, can you explain your question a little bit? I was a bit confused. The first and empty on the second. DF is. Oh, okay. So you're talking about reading this table. Correct me if I'm wrong. Yeah. Okay. That will probably be a whole lecture series on its own, but I'll give you like a very brief like a brief summarization of what the table, how to read the table, because we're still at just the two sample t-test. I also wanted to cover the ANOVA and the paired t-test and the ANOVA 2 sample, but I think we'll just try and narrow down our tests for today and just focus on the t-test and just like work with that one if that is what we need to do. So The means. The means are just basically the average of the insured values for houses that do not have earthquake versus the houses that do have earthquake. That is pretty simple. The variance is basically the variance of houses with the price that have the variance in the housing, the variance in the insured value when you have an earthquake insurance, versus when you do not have an earthquake insurance. The observations are there are a number of observations that we have. Then we get to the pooled variance. The pooled variance, not that important when we are working on when we are assuming equal variances. The pooled variance not really that crucial for our test, but the pooled variance is, I think, the best way to explain it is the variance of our entire sample, the entire sample that we're working with. The hypothesized mean difference is the amount of difference that we are hypothesizing. So what was our null hypothesis? That there is no difference. Our null hypothesis was 0, so that's why we'll keep it at 0. The degrees of freedom. Degrees of freedom is basically, let's say that your number of the degrees of freedom are usually of the whole test. It's not of one group or the other group. It's just common for both tests. So if the number of observations here are 500, so we have 500 observations, and we are dissecting that in two ways. Right? We have 1 and 2. We have 1 does not have earthquake insurance, 2 has earthquake insurance. So it's the degrees of freedom is basically 498, 500 minus 2. It would be 498. So that is the degrees of freedom. The t statistic, it is your test statistic. I cannot go into how it is calculated. That would probably take 2 hours. But in terms of t statistic, that is the statistic. That is the value you are testing. Okay, and your t critical is the significance value. So let's say your t statistic is vastly different. So when it's a two-tailed test, it is t stat less than equal to t stat is less than critical two-tailed test greater less than positive of the t stat. That is our test basically. So if your t statistic is vastly different from your critical, that's when you reject the null hypothesis. And that is what's happening. P value is just another way of rejecting the null hypothesis. T stat is one way of rejecting the null hypothesis. So for example, if I had done this the other way, if I switch this around, if I had earthquake insurance here and not earthquake insurance here, this number would have been positive 9.8. This is what that number would have been. And in that case, 1.96 is less than 9.8. And that's why you reject the null hypothesis. That's one way of understanding it. Making sense so far, Mahesh? Okay. Any other questions before we move on to the test? Okay. So that was the t-test. I was going to show you guys how you can combine what we've done so far and do like a one-way ANOVA. But I think might just take too much of time. Yeah, go ahead, Pratibha.
Sir, we assume their equal variance. So
Yeah.
what if there is unequal variance? Then how will be the results? So can we
So
find out?
that would be a different test. So our test, whatever test, so this is just going into inferential statistics. But in general, your assumptions decide the test that you take. Whatever you assume beforehand about the data is the test that you apply on the data, right? So in this test, we have assumed equal variances, and that's why we've used two sample mean test that is with equal variances. Let's say we wanted to do like a paired t-test. Then what do we need for paired t-test, for example? If like are you familiar with the paired t-test? If familiar, just shout it out.
I am familiar, but right
Yeah.
now yes.
Yeah. So with paired t-test, what would we need? We would need data that is replicated, right? That there is a relationship between the first sample and the second sample. That is when you use paired t-test, right? You use the difference of means
Yes.
when you do paired t-test. Similar with ANOVA with replication, where you have let's say two sample ANOVA with replication. You are replicating the treatment of the first group on the second group, right? So these are all assumptions that we are making on the data. So the test that you pick, it completely depends on the assumptions that you make. So we can't do assuming unequal variances in this one. Let me try if we can. I haven't prepared for that, so let's see.
Sir, means
Yeah.
what I learned actually is if there is equal variance, then we go for the parametric test, means there is normal
Mhm.
distribution and equal variance in the data. And if not, then we use non-parametric test. So I want to show these on Excel, how we can do that.
Non-parametric. Okay. So just because there are unequal variances does not mean that you have to jump to think non-parametric tests, because equal variances assumes a normal distribution. That is correct. You can still do a t-test using unequal variances. That is still fine. But in this case, when our hypothesis is that there is no difference in insured value, we have to use equal variances, because if we use unequal variances, then we have to shift our null hypothesis. Our null hypothesis becomes greater than or less than, it becomes like a one-tier test. Make sense? Because that's, yeah, makes sense? Yeah.
Thank you.
Yeah. If I'm not understanding your question correctly, feel free to email me and I'll get back to you.
Sure, sir. Sure.
Yeah, sure.
Thank you.
Yeah. Okay. Okay, I think it's 6:30. We'll take just a couple of minutes break, and then I'm going to go into the data that we already have. So the data that we were working with so far, this data. So the data where we created a combined table, we're just going to work with this data, and we're going to ask some questions about this data, and we are going to generate some answers about this data. So just make sure that you have this data open by that time, and we're going to have like a quick working session, and then I'm going to give you guys an opportunity to just create some, ask some questions and apply those tests to it. Unfortunately, I apologize because I wasn't familiar. I wasn't fully prepared that there could have been a situation where the inferential not everyone's familiar with inferential statistics. I just went with that assumption. So I apologize in advance. I'll try to keep it as general as possible. Please feel free to ask questions, and we will try and keep this as light as possible, because I think a big chunk of the group that is involved probably is a bit unfamiliar with some of the tests that we're using. So we'll just try and be as general as possible and as general as possible. I think that's it. Okay, so we'll take a couple of minutes break. I'll just go grab a glass of water and then we'll start. Okay. Good. All good by you, Pankaj?
Yeah, it's perfectly fine here. We can have a break for 5 minutes. Yeah.
Okay, I'll be right back. I think everyone good to restart in a minute. Okay. This is शुरू करें. थोड़ा एजेंडा आज के लिए थोड़ा चेंज कर रहा हूँ. हम अपना एजेंडा थोड़ा सा स्विच करेंगे. मेरी खुद की मिसकैलकुलेशन हो रही है, तो एक काम करते हैं. We will go with a quick example of answering a question using the data analysis tool pack. बहुत ही जनरल एक एग्जांपल पिक करेंगे. हमने जो हमारा डेटा अभी तक तैयार किया हुआ है, इसी का एक पिवट टेबल बनाएंगे और उससे एक क्वेश्चन आंसर करने की कोशिश करेंगे. And then we'll move on to setting up Power BI. Does that sound good to everyone?
Yeah.
Yeah. So we'll just try and answer one question, and then we'll move on to Power BI. Make sense? Okay. Yeah, everyone here. Should we get started? Okay, let's get started. Okay, so हमारे पास we'll open up the same data that we worked on. वही data जो हमने पहले use किया था, we'll just open that up. और अब इस पे एक क्वेश्चन आंसर करने की हम कोशिश करेंगे. So ये कैसे करेंगे? We will use our pivot table knowledge that we already used in the past, and then we'll use one inferential statistics metric, a test, to answer another question. Okay, so let's create a pivot table first out of this. So I'm just going to click here, insert pivot table from table. So this is the combined table. We're going to create a pivot table in a new worksheet. So that is our pivot table. Everyone following so far? Okay. So let's say we want to see what is not the unit price. The quantity that was sold in 2023 and quantity that was sold in 2024. This is the sum of quantity that was sold in 2023 and 2024. I'm just going to put city in the row. Okay, so this just tells me that in which city, how much quantity was sold for any of the snacks. We're not worrying about different types of snacks, just any snack that we want. And now, everyone following so far till here? All good? Any questions so far? If not, we'll move on. So हम सिर्फ देख रहे हैं कि कौन सी सिटी में कितनी क्वांटिटी में हम जो हमारी प्रोडक्ट्स हैं वो बिकी. Okay. In order to do, should we do a pair t-test? Let me figure it out. Right. Okay. So, our null hypothesis here is that in terms of the difference in the quantity that was sold across cities, let's take this question. The question is कि जो जितनी भी quantity हमने बेची in 2023 in different cities, comparing that to 2024, there is no difference. मतलब उनमें साल में कोई difference नहीं. that is what we want to check. So let's take our first variable as 2023, second variable as 2024. Our mean difference is going to be 0, and the alpha is just going to be 0.5. So this will give us our t-test. So the variable 1, if I remember correctly, what did I pick as variable 1? I think I picked 2023 as the variable 1, 2024 as the variable 2. So what question is this trying to answer? So the question, again, I repeat, the question was, the hypothesis was no difference between 2023 and 2024 in terms of sales. That was our question. Okay, across cities, we've just divided it into cities, but between 2023 and 2024, there is no difference in sales. So let's look at our paired t-test. The number of observations is exactly the same. It's 237, and the variance of the mean. The mean, yani ki the average number of product that we sold in 2023 is 62. The average that we sold in 2024 was 109. So there is significant difference. You can already see here. What our paired t-test tells us is that these two samples, which are related to each other, if you try and these two samples which are related to each other but are different in some way or the other. So let's say a class before it has gotten 30 बच्चों का class है. There's a 30 student class. They have gotten no education so far, and you ask them to take a test and the results of that test, versus once you have taught them something and then you take a test and the results of that test. Un dono mein, the difference between those two is what a paired t-test compares. So for example, in our example here, what we are trying to compare is that this quantity and this quantity are significantly different than each other. मान लो कि 2023 की sales देखकर, let's assume that looking at the 2023 sales, the company launches an ad campaign, and then it tries to compare the sales in 2024 of the same location ID and the same product ID, and then it wants to compare whether this ad campaign worked or not. मतलब इस ad campaign की वजह से कोई difference आया है या नहीं आया. Again, the hypothesis is of no difference. The hypothesis is not greater than or less than. It's of no difference. मतलब कोई difference नहीं आया है. वही हमारा hypothesis है. Or our hypothesis is actually rejected, which means that there is a difference between the two. Okay, makes sense? Makes sense so far? Any questions? Okay. So now let's try and do a little bit of a working session. So I'm just going to show for those who have a little bit of a grasp of the ANOVA system. I'm just going to show you how pivot tables can help you generate ANOVA. Even if you don't understand what ANOVA is, just understand that I'm just trying to show you how to generate results for ANOVA using pivot tables. हम pivot tables use करके ANOVA with replication हम उसके results निकालना चाहते हैं. That is what we want. हम उसको समझने की कोशिश नहीं करेंगे क्योंकि I don't have time to. I think that will have to be its own lecture series. The inferential statistics will have to be its own lecture series. And I understand that the group. I misjudged the group. So I'm just going to try and show you in the next 10 minutes how to create a two-way ANOVA. And you can just keep that information as how to create two-way ANOVA, and we can get into the explanation later. We don't have to get into the explanation. Okay. So in terms of two-way ANOVA, what do you need? You need data that is ANOVA two-factor with replication. If you want to create a test for ANOVA two-factor with replication, what do you need? You need data that is structured along the columns, not in this way though. You want so you want 2023 observations, and then you want 2024 observations, right? So what you can do here is put category, and then I'll put city. Yeah. So this way, your data is actually structured in two different in a cross tab. And now from this cross tab, I think you can generate a two-way ANOVA. Wait a minute, I think I'm wrong here. Something's off. Something's off. Should be here. Just give me 1 second. I think this is the wrong sheet. Give me 1 second. Okay, regardless, let's just work with what we have. Where is it? Where did my sheet go? Oh, there it is. Okay, hang on. Okay, so in order for your two-way ANOVA, I think you need observations in every column, so we can't use city. So it's city. Let me try and use region. Does that work? Yeah, kind of works. No, I think we still don't have it for crackers. So I'm just going to add a filter for. Let's add a filter for category. One pick crackers. And put product in the columns. Okay, do we have observations for everything? Still don't have observations for arrowroot. Okay. Okay, so I think this is much more of a data that we can work with. So now we can try creating an ANOVA with replication. So the input range is going to be this whole range. And the rows per sample is going to be, we have 2 rows per sample, and the alpha is 0.5. Non-numeric, where is it? Oh, come back. Oh, okay. Sorry about that. What? Okay, this is going down very bad path. Okay, let's see. I'm just going to go down. Any questions so far in terms of just generating inferential statistics and stuff? Any questions just in general, like in terms of just generating inferential statistics and not actually interpreting them, just generating inferential statistics? If not, we can just go into setting up Power BI, because I think that's probably going to apply to more of a group than this stuff is going to. So let's just go into Power BI. Let's just try and learn that while we are here. Okay, everyone good with that? Anyone has any objections? If you have any questions or anything else you want to follow up with me, you can feel free to email me. And if you want to know more about the inferential statistics side, you can email me on that as well, and I'll follow up. Okay, so let's just work with Power BI. And in order to work with Power BI, you first need to have Power BI downloaded. How many of you have Power BI already on your computer? Just give me. Okay, one person has it. 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. 6 people have Power BI already on their computer. Put your hand down. Yeah.
Hey, we have already shared everything with them. Link to download
Okay.
Power BI. I think
Okay.
you please move with the session and whatever you are gonna teach. If they don't have, they can download. Link already has been shared. So I think.
Okay, great. Okay, great. That's amazing. Okay, perfect. Perfect. That's fine. Okay, then I'll just move on to just generating data visualizations using Power BI. So what is Power BI used for? So I'm just going to give a brief introduction for what Power BI is generally used for. It is one of, while it is a great way to present, it is a great way to present your analysis, your research. It is also a great way to, it's a great monitoring tool. That's what I would say. I can show you guys a real life example of how Power BI monitoring is done. Power BI monitoring, so what in my work, what we do is we generate some Power BI reports and we give those reports to our clients or the stakeholders. The stakeholders get the reports, and these reports are quite detailed. The amount of data that you can load onto a Power BI report is actually astronomical. Power BI can handle way more data than Excel can. Just understand this. You can feed your Excel sheet into Power BI, but there is an amount of data that Power BI can handle that Excel cannot. I'll just give you a quick example of that. Just give me 1 second. Just try and give you a quick example of it.
Power BI is not available for Mac, right?
It should be. Mac Power BI should be available for Mac. Not natively available for Mac OS. Can access and utilize Power BI through. Okay. So yeah, it's not available on Mac. Wow. Yeah, I wasn't aware of that. Not compatible with Mac. Oh God. Wow. It's the one time you'll regret having a Mac, Gaurav. Yeah. Anyway, not much we can do about it. You can probably try and see if you have if you have access to another computer, a Windows computer, where there is a Power BI already available. You can try and see if you can get something like that. Yeah. Anyway, I'm just trying to try and find an example. For some reason, I'm not able to find it. Okay. So I'm just going to open and show you guys a report that we use in our work. And this is just to give you an idea of how much data can Power BI handle. Okay. Pretty slow to respond. What this report is, it's basically telling a particular region This is their OR monitoring. So this is how much patient allocation, time allocation that they are allowed to give. So each division, how much time do they need in order to make sure that they complete their surgeries? And that is what this report is. Now, if you look at this report, it has like a parameter section where it goes into all the different hospitals, all the different services that they provide, and even goes down to the clinician level. It has all the care types, and you can date range this data. The data actually ranges from the start of 2018 to today. So this data is pretty huge. And this data does not come from Excel. This data that we are using, it is completely drawn from a SQL table. You can connect your SQL tables with Power BI. That can be done. And once connected, these become like an extremely powerful tool in the world of monitoring and evaluation. Right now, if you go anywhere, any organization that does any kind of monitoring, they are using BI. They are using some sort of BI tool, whether it's Power BI, whether it's Tableau. They are using something along the lines of these to monitor what's happening in their organization. The great thing about this is that once your data has been updated, all you have to do is just refresh. I can't click on it right now because I'm not connected. But if I click refresh on this, whatever the updates have happened will automatically update here. And this is one of the tools that surgeons and the head of divisions sometimes use in order to figure out how much time do they need to allocate for a particular doctor to complete the amount of surgeries that are listed for them, which is called slating. That is all done using these sort of reports. So this is the use case for Power BI. I would probably say that the use case for Power BI, it is like an evolved and upgraded version of Microsoft Excel, where Microsoft Excel was able to do this. Microsoft Excel can do some of this monitoring stuff. We still do some of the monitoring stuff with Microsoft Excel, but it is getting dated and aged fast. It is getting out of date really fast, and it is being replaced by Power BI wherever possible. So there are some things that you can't do with Power BI as well, but anything that you can do in Excel, you can do in Power BI. Another thing that is great about Power BI is you can write your own queries. You can write your queries in Power BI and execute those queries and analyze your data in Power BI. However, I'm not going to go that deep. We're just going to try and create some basic level visualizations because I don't think we have that much time to go into writing queries for Power BI, but that is also what you can do. If you go down the rabbit hole with Power BI, it goes deep, and it is huge. There is so much to learn here. Okay, so we'll start by just uploading our data. Just try to what we want. We'll work with the same data that we were working with. So the food sales data, I'm just going to close and save it so that Power BI can access it. So all I'm going to do is, once you have this home page, click on import data from Excel. Once you have clicked on import data from Excel, go to your file, open your file. So then this sort of a dialog box will open. So this is all the worksheets that already existed in your Excel file. You have to pick the ones that you want in your data, right? Only the ones that you want. So you know what? I'm just going to take the, also reminder, if you have marked something as a table, it will also open the table. So for example, the sheet food sales 2023, let me see if I have it open. Still, I don't have it open. I'll have to open it up. So the sheet food sales 2023 has a table sales data. So it is showing sales data as a different table that you can just download, put it in. What this does is it saves Power BI time of converting the sheet that you've given it into a table. if you already feed a table into it, it saves Power BI some time in terms of creating the table. But you can actually just feed your whole sheet and it will still try to convert it. Okay. So I'm just going to take sales data for 2023 and sales data for 2024, just going to save Power BI some time. And I'm just going to do a load. I can also do the combined table, but the fun part with Power BI is everything we did before this in Excel to make sure that our data can be analyzed and visualized, we don't have to do in Power BI. We actually don't need to put we don't need to have a combined table all together in order to analyze data in Power BI. You can just have your raw data, the sales data 1 and 2, and you can just load it. And then you can analyze it here. I would still I would still try to have a combined table, because when you have a combined table, the benefits are that you don't have columns that are just that have the same name. That is the benefit. So you don't have columns that have the same name. For example, the quantity in 2023 table and quantity in 2024 table will have the same name when I download it. But if you have a combined table and you download that table, then you have quantity 1 or quantity 2023 and you have quantity 2024. So you have a distinction between the columns. But you can still do it. So let me see what the errors are. So you saw that there was some error here. Power BI suggested that there is an error in our data. So the error is regarding the index stuff. So this is the indexing stuff that we did, and that column has an error. The error is basically that it is empty. That is the error. So what we are going to do is we are just going to, you can do multiple things. You can actually just remove these columns, but we don't want to do that, because with Power BI we have the option that we can actually just keep this data in. So I'm just going to error and replace errors, remove. So you can remove errors, you can replace the errors. And there's also one section where you can keep the errors. Where is it? Okay. Where is it? Forgot what it is. Why is it not in the drill down? Should be here. Should be in the drill down. Oh, there it is. I had to click. So remember to click in this green area. Don't click on here, or it will just give you something just completely different. Just click in the green area. So just type keep errors, and then it will keep all the columns that actually have the errors. Okay. And then I'm just going to close this, apply your changes now, click yes, and then you'll have both your tables loaded onto Power BI. I'm going to stop here and see if anyone has any questions so far. Any questions? If not, show of hands, how many of you tried loading your data onto Power BI now? Like while we were doing it, did anyone try? Mahesh tried it, Sanita tried it, Hindol tried it, Diti tried it, Ramya, Saad tried it, I think, Devraj, okay, Gitanjali. Okay, so everyone tried it. Everyone happy with it? Anyone has any issues with it in terms of loading the data? Yeah, go ahead, Monica. Have a question? Okay, seems like it wasn't a question. Just check the chat. Okay, no questions. Okay, so now this was loading your Excel data into Power BI. I do want to see if there is, if any, so how many of you work with sometimes text or CSV data and you want to see how to load that onto Power BI as well? Or do you guys work with text CSV or sometimes SQL Server data? Anyone? Raise your hand and I can show it to you. Okay, so looks like no one works with text or CSV or SQL Server. Everyone works with Excel, so that's fine. We can just keep it to that. But in case you're curious, text CSV is just as simple. Just pick your CSV, just click open, and then it will load onto your data just like that. And then you just click load. So text and so this text CSV is actually exactly the same as Excel. Where it does get different is when you go to SQL Server. When it's about SQL Server, what you have to do is you have to mention your server name, your database name, and then you have to do an import, and then you have to write a statement, a SQL statement to import that data, and then you click OK, and the data gets imported. Make sense? This was just a quick fire way because I think most of you just work with Excel, but I hope that was just a brief overview of how to download data in Excel in Power BI. Make sense? Okay. Okay, so now for the fun part, which is, just first remove this fun part, which is creating data visualizations. Now, this one is this section is where it's not just about your analytical skills, it's also about your data presentation skills. So when you're working with data visualizations, there are some golden rules of data visualizations. I'll share those in the next class when we're working before we actually go into creating data visualizations. But I'll give you a brief overview of what does a good data visualization look like. A good data visualization is not overwhelming. That is the first thing. If your data visualization is complicated, अगर आपने जो बनाया है वो समझने में, उसको देखकर समझने में अगर किसी को 5 से 7 मिनट से ज्यादा लग रही है, especially if you're presenting it, it should not be more than 30 seconds. 30 seconds से ज्यादा नहीं लगना चाहिए किसी को भी समझने में कि हो क्या रहा है. That is the rule if you're presenting. If you're submitting to someone and someone's taking a look at it later, it should not take more than 5 minutes. If it takes more than 5 minutes, you've lost the person. Okay, so it has to be as simple as possible, but also as detailed as possible. That is the first rule, and just make sure that rule is always in your mind. Kitne bhi, when people are making really complicated Power BIs, it does not actually look good. Like I have an opinion on the one that I've just shown you, that जो हम लोग work में use करते हैं. We are right now upgrading on it because that just looks clunky. It just looks like everything has been just emptied onto one sheet, and that is not how it is supposed to be. It is supposed to be smooth, silky, and it's supposed to be a fun way of presenting your data. If you look at it and you see something, and if you look at it and if you understand it, does not mean that your audience understands it. So you have to make sure that you keep it as simple as possible. Okay, so let's try and build one. Now, the good thing about Power BI is when you change one selection, everything changes on the same on the same page. So for our page, we'll start building our analytics. So what I want first is I want to have a bar chart, and you can try doing this with me, and you don't have to do the exact same thing as I am doing. So you can just try on your own. Try doing something like this on your own. So I'm just going to show you how to create a bar chart first. So you pick your visualization, whatever visualization you want to pick. I'm picking a bar chart. and I'm just going to put let's say region in my x-axis. Oh, sorry, no, y-axis. I'm going to put region in my y-axis, and I'm going to put the quantity that was sold in x-axis. So this is just the sum of everything. This is just giving me a sum of quantity that was sold in the x-axis, the sum of quantity that was sold in the region east or west. Now, if I want to change, if I don't want it this way, I can just change it here. Just change it like that. Oh, sorry. My bad. Oh. Okay. So I think I'll have to choose like a bar chart for that. Okay. So when you choose a bar chart, it just changes completely. You don't have to switch that around. You can just choose a bar chart. Let's say, see cities instead of regions. Let's remove. So you can have this region with it as well. So West, East, Boston, New York, Los Angeles, San Diego. You have this this sort of a thing as well. So basically, it's just drag and drop. Creating visualizations in Power BI is usually just drag and drop. I'm just going to stop there and see if there's any questions. No questions so far. Okay. So just the basic on creating visualizations. Actually, I just remembered. Sanhita, you sent me this one, right? Your assignment. Yeah.
Yes.
Let's try. So you know how I was talking about the visualization in this table? Let's try and manipulate some visualizations. Let's try and create some visualization based on what you've done. So I'm just going to go to get data Excel workbook. Just going to try and see data assignment that up. I'm just going to pick your combined table. Going to load it on here. Okay. So just going to create a new page. Okay. In this new page, I'm just going to try and why is it? Why is there no names in the column? Column. Oh, okay, that's why. So I think we messed up. There were the names were in the second column. So if we want, this is actually a good way to learn as well. So the names were in the second column. So what we need to do is we need to put date, day 2, assignment, click OK. And then when this pop-up comes here, select this, preview, let it load, transform data. So transform column 1, type in rotated headers. Why is it? Why did it not give me the option? Give me 1 second. So settings, page management. Okay, so because our first column was sort of like a joint table sort of on thing on top, it has taken our first row as like it has not taken our first it has taken the first row as the header row and not the second row as the header row. So what we do in that case is just click this one and just use first row as headers, and then your entire first row will become the header. Make sense? And then you click and press yes, apply the changes, and now it should show, yeah, now it is showing all of these as their as what they're supposed to be, and not not just not just columns. Now it's showing the names of the columns as well. Okay, so let's look at what Sanhita tried to do. Okay, here I think when we were creating this, you were trying to create a line graph for this, right? The country and the sales, right? So what you can't do with Excel, but you can do with Power BI, is create a sort of like a tree chart, a tree map. A tree map would be perfect for what you were trying to do. So let's say, what's happening? What's my computer not responding? Okay, it is. Okay, so the category is country, and let's say the sales is actual price, discount, list price. Is it just price? Where's the sales? Let's double check the data. Sales, there is sales.
Actually, there was no column named
There's
sale.
no sales. Okay.
Actual price, I used it at sale. Actually, I renamed it in
Oh,
pivot
okay, you renamed actual prices. Okay, so let's just do that then. Let's just use actual price 2024 as like our as the value here. So this is also something you can do. It is overwhelming right now, but this actually gives you a great idea that, okay, USA is actually consuming most of, the USA has the highest price, or it has, if you're using it in terms of sales, USA has the most sales. This sort of a chart cannot be created using Excel. Now, going back to our first tool, do you think this is overwhelming, Sanhita? Just asking you a question there. Would you use this?
Yeah, but actually for USA part it's understandable, but for others it's
Exactly. Yeah, it's not understandable. It is a little bit. It is too much. It's too on the nose. So that's why we will probably switch to like a bar chart where it is actually making more sense. Right?
yes.
Is this much better?
Yeah, much better than tree.
Yeah. Okay, I think there's only 13 minutes left, so I can't actually go into the visualizations right now. Okay, let's do one thing. Considering there's only like 12 minutes left, let's try and do an exercise. Okay, everyone up for it? Everyone that's alive, up for it? Okay, let's do an exercise. The exercise is, if you have access to Power BI, I want you guys to just try importing the data and do whatever, create whatever visualizations you want. Just try playing around with this for the next, just try importing and playing around with it for a little bit, and follow up with me if you have any questions. Okay, and I'll answer them. Tomorrow, what we're going to try and learn is the rules of data visualization. There is one thing called the text to data rule. So amount of text you show on your visualization, compare that to the amount of data that you're showing. Is the information that you're giving still if the information you're giving is actually conveyed by less text? So we'll go into that. We'll go into how to create a dashboard. So right now what we're doing is creating visualizations. Tomorrow we'll go into creating a dashboard, a fully functioning dashboard that you can just click on one page and the filters apply to all pages, or you can click on or you can keep a filter to just one page. You can actually create an entire I'm going to use some other data because this data is not great. I'm just going to try and see if I can work something out with this data. But if I cannot, I'll probably use some other data. We'll go into what kind of different insights can be generated using Power BI and how quickly it can be done. I am going to create a dashboard tomorrow within an hour, and I want you guys to also follow along. So we'll have half an hour just for that, if in case it goes over. But within an hour, tomorrow, we're going to create a new dashboard. Okay. In the meantime, I want you guys to just start creating some visualizations. Just play around with Power BI, just import your data and just do whatever you want. Just go crazy. Just try to see if you can actually get familiar with the clicks, with what Power BI does. Let's say if I already have this, and if I don't know, insert just a random chart, let's say like a bar chart here, and I'm just inserting on this bar chart, I'm just inserting this randomly region in the y-axis, and then I'm just randomly putting total price in the x-axis. They go, what happens? What happens? What changes? Nothing. Okay, then if I just remove the region and if I put let's say the city here, and I remove the region. Oh, this is the wrong data. Sorry. I'm using the wrong data. That's why. Region and actual price. Okay, so if I now click on Ireland, what happens? Okay, Ireland is an EMEA country. Okay, I can find that out. I can click on USA and it's an NA. I click on India and it's an APAC. So that it actually just try and play around with this a little bit. How to change colors, what you can do to make your visualization look better. Is there anything? So just try and play around with it for the next 10 minutes, 5 minutes or so, and for the rest of your day. And I do want to see if you actually give it a try. I do want to see what you are coming up with. Just try to design one page, 4 visualizations. Single page, 4 visualizations. Just try whatever comes to your mind, and just give it a go. Just give it a go and see what you learn. If you can learn anything from it, great. If you need more help, we'll discuss that tomorrow. Yeah, I unfortunately can't go into much deep of Power BI right now because we have very limited time. So I'm just going to open for questions if anyone has any questions. Okay. So yeah, I think we can reconvene this tomorrow. I'm sorry for today's session. I had an entire thing planned for today's session, but I think it was a curveball when I asked you guys. I didn't think of the fact that many here are from social sciences background. I completely forgot about that fact, and I had the entire thing planned to go into different types of inferential statistics, and yeah, so I apologize for that. It's my bad. But yeah, I will try to cover Power BI as much as possible because I think that is common between social studies students and people who understand analytics. I think that's just going to be something common. So we'll try and cover that tomorrow. But yeah, I apologize for today. It's my bad. Yeah. Anything that comes to your mind, Pankaj, that you want to discuss?